Okay, so thanks for joining in. If you don't know me, my name is Jitesh. We are going to have like a Spark Streaming masterclass on Spark Streaming today. Let me take you through the agenda. And before I go to the agenda, if you can type in the chat, like how many years of experience with streaming do you have? Is this the first time you're trying streaming? And have you worked with Spark before? So, have you worked with Spark before? How many years of Spark experience do you have? Have you worked with streaming before? And how many years of experience do you have with streaming? So, four questions. Okay, let's get on to the agenda. And hopefully, you folks can hear me. If you cannot hear me, please type in the chat. I'll just keep an eye on the chat as well. So yeah, this is the agenda for today. So about me, we're going to do a short intro on Spark Streaming. Then we are going to spend a majority of the time talking about doing like a live demo. And the way I have designed this is there is something for everyone. So if you're new to Spark, there's something for you. If you have been building Spark streaming applications for 2, 3 years, 4 years, there's still some in-depth content for you. So I've tailored the content for both the audience, someone who is just new, just getting started with Spark streaming, learning about it. And then for folks who have been working with Spark streaming, we are also doing a deep dive for them. So that way both the audience get addressed. And then we'll talk about keeping in touch, how you can connect with me, and we are going to in the end talk about the next session which is planned maybe 2 weeks from now, and then we'll have a dedicated Q&A, and in that Q&A you can ask any questions about this topic, but if you have questions about your own problems, like your own problems which you see in data engineering or streaming, we can discuss those as well. Yeah, let's get started. So about me, if you don't know me, my name is Tesh Soni. I write under the pen name Canadian Data Guy for the last 2 years. I've been creating technical content. Most of them was blogs, and now I'm got into getting into YouTube and doing live videos because I honestly don't like reading a lot, believe it or not. And I learn a lot watching YouTube myself. So that's why I'm just addressing the people who want to watch technical content but prefer videos over written material. Yeah, I why should you hear me? Why should you bother hearing me? So I have 12 years experience in data engineering and data architecture. I spent 6 years at Amazon and AWS and 4 years at Databricks. So I have 10 years of solid experience where I have only worked at large scale. Um, yeah, and for the last 4 years at Databricks, I have been taking streaming workloads to production almost every week. So lots of in-depth experience on streaming. So I'm trying to give you the content which I did not get when I was starting my streaming journey. So hopefully this resonates with you folks. Okay, so disclaimer. So anything you see on the slides or in the demos today is coming from my personal knowledge, experience, and opinion. It does not reflect any endorsement from either of the companies I work for or have worked for. So everything you see is my opinion. It's for education material only, but you should definitely try it out. I write, I only give out content which works or has worked at least when I'm trying it out. Okay, and one last thing, um, which is you can keep asking questions in the chat. I'll not be immediately be able to address them, but what you can keep doing is don't wait for the topic to finish or don't wait till the end of the session. Just keep posting your questions, and then I'll take a look in the end and answer as many as I can. And I love questions. If you don't know me, I actually enjoy questions. Even if I can't answer them, I'll just let you know if I can't answer them, but I love questions. So, why real time or why streaming? So, this is a quote from Gartner, which I really like. So, decisions will be made in real time, regardless of whether real time analytics is available or not. I think that's just a very good summary. Like, world works in real time. If you can work at the same speed, good on you. If you cannot, you're going to just lose out. I think that's the crux of why you should be doing it. So why don't folks do streaming actually? Let me just check the chat once. Okay, things are good on chat. You folks are able to hear me, which is good. So why are folks not able to do streaming? So the biggest reason is that it is complex. There is a small learning curve involved, and historically people used to have separate systems. Like 4 years ago, you would have like a real-time system which would be Elasticsearch powered. It could be Spark powered for the batch, and then there were two separate systems, which was one which was doing just pure real-time stuff, and then another system which was just doing pure batch stuff. And then what you'll do is create a layer on top, which would either logically or logically represent the combined data set. Combined, when by combined data set, I mean the real time data set, which was trying to operate near real time, and the batch data set. So we had this paradigm where the technology was too complex a couple of years ago. And now either people are stuck in that technology stack. That's one of the reasons why people are still hesitant on trying streaming, or they are not aware on how the systems have evolved, or we haven't like, or we are aware, we just have not got time to look into it. um okay, let's go on. um so this is another slide which I like, which is about, hey, for different latency, what you can do, right? So if you are working in a daily, weekly, monthly fashion, you're probably into forecasting, or just doing basic reporting and basic analytics, right? um if you are at a hourly cadence, where you process data every hour, say you are Amazon and you're trying to figure out how many orders came in the last 1 hour, and then you're trying to make predictions on how many how many employees to bring in to package the stuff up. So basically, or you are Instacart, which is you have a bunch of deliveries scheduled and now you're trying to respond to it, right? So when we come into the hourly category or the minute category, at least I would say you're approaching the near real time paradigm. And then there is true real time, which is, hey, like YouTube Live is an example where I go live, you folks get a notification, which probably happens in milliseconds. Or you order something on Amazon's webpage, which is you're responding to event, but you're responding them to in real time. So this, when you are in the millisecond range, is called true real time. If you are in the seconds range, it's called near real time. And minutes to hoursly, you can say, is your traditional batch. So where does Spark currently operate? So Spark actually supports both of it. So Spark supports true real time. There is a Spark streaming has a specific mode for that. It's new. It's still experimental. But if you're thinking like seconds, like 1 second, 2 second, 3 seconds, or say between 1 to 10 seconds, anything, your Spark streaming has a mode called micro batch mode, which is the default mode as of now. That can easily operate in the near real time mode. So just for clarification, I think if you're trying to design something for less than 800 milliseconds, I think right now the best technology is Flink. And if you get above 800 millisecond benchmark, Spark streaming just becomes your friend because it's just so much easier than Flink. So how should you decide what should be your latency? So the way you decide is you ask the business, what does this business need actually, right? Not everything has to be real time. um, because if you do things in bulk, you essentially can optimize for cost because you'll get better CPU utilization. And the more you try to do it real time, um, you get into the territory of things getting more expensive because you're trying to get greedy. You're trying to minimize latency, means you'll have to give more CPU power. Uh, that being said, if you're in the minute range, you have like a very good balance, right? I think you can achieve both low latency and low cost. When you are ultra optimizing for latency, say 5 seconds, 3 seconds, I think at that point you probably are using more compute than you need to. So that's how I think about it. So you ask your business on what's the use case. Say you are Instacart and you need to get packages scheduled to be delivered, right? So that kind of thing, you need to understand, hey, what's the frequency on which we're going to get the order scheduled? Say business says every 1 hour we want the orders to be scheduled. Then my thumb rule is divided by three. So if someone says I want data in 60 minutes, I divide it by three. So my processing time becomes 20 minutes. The reason I do that is because in case I have a failure, or in case the cluster has a failure, whatever failure happens, failure is a part of life, then we have 2x the time to recover. That way we'll not miss our SLA of 1 hour, but still be able to achieve the output. Okay, why Spark structured streaming? So the first point, honestly, is my favorite, which is you don't need to start learning a brand new paradigm. The same APIs work, the same engine works. So this unified API layer is what I really enjoy about Spark Streaming, such that I don't have to learn two frameworks at once. I can just enhance my understanding of Spark Streaming, and then I'm done. Other than that, obviously, fault tolerance and recovery is there. If a failure happens, that's automatically handled. Another thing which I like is you don't have to worry about duplicate processing of data. You don't have to specify what is there outstanding to be processed. So Checkpoint handles it. Let me give you an example. Say you're processing your advertising data, right? And say let's take Amazon as an example. Say you're processing Amazon's ads data set. An ads data set from an industry perspective does not stabilize for like 3 days. So for 3 days, clicks and impressions can be delayed by 3 days. So historically, what one could have done is, if you understood that data did not stabilize or the whole data does not arrive till 3 days, every day you will process day minus one, day minus two, and day minus three, because you could not identify which day is complete or not. So you'll just process it. So essentially, you're paying 3x the cost. Um, and checkpointing just takes it away from you. So checkpointing says you don't worry about what's net new. I'll identify what's net new and only process that. And that's where, by the way, how things become cheaper also, because you're only processing data what needs to be processed. Performance throughput. So you can do 14 million events a second. I have personally done 5 million events a second, and 5 million events a second, if you sum it up at a month level, it's close to a petabyte. So you can really, really scale this thing. Okay. This is one of the memes I came up with. So this is a common misconception in the industry, where when people think streaming, they think continuous. So when I say streaming, you should understand incremental, that we are doing incremental processing of data. You should not think that this is continuous. So streaming is very good. Spark streaming is very good, that you can choose if you want to be continuous, means you want to run all the time, or if you want to run every hour, or if you want to run every 15 minutes, or you want to run once a week. So you can still be streaming without being continuous. So that's the flexibility which Spark streaming offers, and it's very commonly misunderstood. People hear streaming, they may think continuous. Continuous, they think is expensive, and thus they're like, oh, we don't want to do this. So just for clarity, Spark streaming means incremental. Okay, so top reasons to start streaming today. Apart from the fact that it's a hot area, most of the engineers are starting to do this. I think Databricks has a metric of 14 million jobs are scheduled every week which are streaming. I might be wrong. I saw it on YouTube somewhere. But it's a hot technology. And if you're trying to get to better jobs, being on a newer technology stack helps you crack your job, because um, you if someone hires you, they know that you know the technology stack. Now you need to just learn the business, so you'll be productive very soon. Whereas if you come from an older stack, you have to absolutely nail every part of the interview. So that's what I feel, which is one should always be on the latest technology stack, or at least on the popular technology stack, because it helps in the career growth. It helps in cracking your next opportunity, even if you don't absolutely ace your interviews. Okay, top reasons to start streaming apart from career growth. So, one thing I told you, a life without input parameters. So, we are saying, hey, let's process the data, and let Spark worry about what is there to process. Like Spark, specifically Spark streaming will worry about what is there to process. I don't have to worry about. I don't have to tell it which days data has arrived. So, like in your traditional batch jobs, you specify input parameters, right? Like a date parameter, or a country parameter, or a marketplace parameter. In streaming, you don't need to do that, because streaming already takes care of that. The second point, which is you can decide to change your schedule anytime without making code changes, or minimal code changes, I should say that. So if you have a streaming job which you today run once a day, and tomorrow you want to run it every 4 hours, you literally just have to change a line of code, and you are going to start processing the data every 4 hours. So even if you are doing Spark batch jobs today, and your business does not have a reason to do streaming, I would still say get onto the streaming paradigm, because when the business reaches a point where they are like, yeah, we want better SLAs on this, then it's a small code change for you. So you're going to upskill yourself, because you learn a new stack, you learn about streaming, you'll still be able to meet your business needs. And if the business says, hey, we want better SLA, then it's a small code change for you. It's literally one line code change for you. The fourth point, which I gave with my Amazon advertising example, which is it helps you drop cost, because if you are in a batch system and your data does not stabilize, or you have late arriving data, usually I see people keep reprocessing the older days. So you'll be able to get away with it. And that's where the cost savings would come in, which is you are only going to process what needs to be processed. That's it. And that's where the efficiency would come in. Top reasons not to do streaming. Trust me, I'm a very transparent person, and I spent half an hour at least twice thinking, why shouldn't one do this? And for the last 4 years, I've been working with so many clients trying to get on them onto streaming, and I couldn't think of many reasons apart from the learning curve. So apart from the fact that you don't have the time to learn about checkpoints, you don't have the time to test your jobs, and maybe hard. This is a debatable thing which I'm going to say next. If you have a lot of complex aggregations, then maybe Spark streaming is not the right tool for you. But even that is debatable. Like I can give a counter argument right now to say why even for a complex aggregation use case, streaming is a better one. But I'll not get there. But these are the reasons you shouldn't do streaming, which is I'm saying kind of there is none, except that there is more learning curve and a time to do some testing. So how is the Spark job different from a Spark streaming job? So Spark job essentially you can think as three components. There's the source, there's the transformations, joins, aggregations, and then there is a target. So source, transform, and target. How is the Spark streaming job different? The Spark streaming job has just one additional concept of checkpointing. And then there is a caveat that not all sources have support for streaming. Example, if you're reading from Kafka, Kinesis, Event Hub, anything on S3, ADLS, Google Cloud Storage, all of those can be streamed. But if you have Postgres table as a source, that cannot be streamed. If you have a Snowflake table as a source, that cannot be streamed. So that's the limitation right now, that not all sources can be streaming. But between Kafka Kinesis and any file type on S3, you absolutely nail it, which is you essentially cover almost all a lot of use cases. Okay, so now we after this slide, we'll directly get into the demo, and then I think it's going to be very deep down. So for beginners, I'll show you the initial code such that you can copy the code, you can make it your own, and you can develop your first Spark streaming job today. And for people who have been building Spark streaming jobs, we are going to open a checkpoint and actually show you how a checkpoint works, how Spark streaming works, how it's able to do fault recovery. So that's how we are going to split our time next. Before we go there, let me explain you the Kafka architecture. So Kafka, Kinesis, similar story. They're almost the same behind the scenes. So so Kafka is a distributed message engine, if I can say that. So in this example, there are three nodes: node 1, node 2, node 3. So node 1, node 2, node 3, which we are saying data is distributed across three different machines. And within those machines, there are different partitions, partition 1 to 6. So what we are saying is data is distributed across three machines across six partitions. That's how data is distributed. Topic, you can think is just a table name. That's what a topic is. So topic is analogous to a table in a database. And then within a partition, you'll have messages. Messages could be thought as rows. So in a database, you have row. In Kafka, you have a message. Every message has a offset number with it. Offset or sequence number. That's the terminology there. And every message can be uniquely identified by a combination of topic, partition number, and offset number. So that's always going to be unique. And one misconception which people have sometimes is offsets are not always contiguous. Meaning, um, offset could it's not necessary that three needs to be followed by a four. You could have zero followed by a two. And why it's important, I'll tell you later. But just remember, topic means a table in a database, message means a row in Kafka. Um, Partitions are just chunking of data, that's the methodology. And every row, aka message, can be identified by the combination of topic, partition number, offset number. That's about it. Now we'll get into the demo. And yeah, like demos are never done. So I'll show you how I'm doing this. So by the way, if you don't have a Kafka cluster, like I didn't have for this demo purposes, so what you can do is you can sign up with Confluent Cloud. They give you like $300 of credit. And then they had a sample topic, which is they are creating some sample data for us to process. And yeah, if you right now I'm not creating a lot of records, probably 2 messages second, and I have 20, like 19,000 messages outstanding. If you do, what I'm trying to say is you have only $300 of credit. If you are trying to do like a million records a second, I got burnt. I burnt actually $1,000 with Confluent one time because I didn't keep a tab on the billing. So just keep a tab on billing if you get into the million records a second range. This demo you'll be done, I think, in less than $2 or something, which they'll cover as part of credits. But just you to be aware, like you, I tried to do it with AWS as well. It was very complicated to have like a public Kafka cluster. So if you're like me and you're just trying to learn, just go to Confluent, get up, use their $300 of credit, get a cluster, get some data, and start doing your stuff. And that's going to be very cheap. Okay, so now I'm into Databricks. I don't know how many of you folks are using Databricks or not. So for Databricks also you will get credits. So you can sign up for Databricks and run this in your code. Even if you don't, first of all, you will get credits. But even if you don't get credits, I think this is $1 an hour kind of a thing. The amount of cluster. So I'm for clarification, I'm just using a single node machine with 4 cores. That's the cluster which I'm using. I think it costs like 20 cents an hour or something. Now we'll get into the code. Sorry, that was a lot of intro. Okay, so first things first, which is for any job, you need to have parameters. So I have created a scope. So I have to store Kafka's secrets somewhere. So basically, to connect to your Kafka cluster, you will need to have your server's address, and then you'll need to have a secret key and a secret value. And you need to store that inside Databricks such that it doesn't get exposed. So this is the code on how you can create a secret and how you can store it securely. And other than that, I have just like a topic name which I'm trying to read, a target table which I'm trying to write, and checkpoint where like checkpoint is where I'm storing my checkpoint. It's just a location. Okay. So let's go through it. So this is the secrets list command. This actually lists all the secrets which are in a scope. So I have two secrets, Kafka API key and Kafka API secret. I run this command, which is secrets.get, which basically gets my username and password into two variables. And now look how simple it is to just start processing data. So here is the code which is going to read data from Kafka. Pay attention to this. There's only like 3-4 lines here which you need to pay attention. So this is just plain reading call, which is here, which we are giving the servers, Kafka server details. We're giving our username and password. I'm using plain mode. You can use a more secure mode, of course. And then I'm saying subscribing to that topic. So I'm saying, hey, go read the topic which we created in Confluent Cloud. Uh, our topic is called stock price or something. And then we are saying, hey, go read that topic and start reading that topic from the earliest date possible. So whichever is the earliest message which is stored in Kafka, let's get that. This is very important because the default is latest. So what happens is sometimes people don't specify it, and then they don't have any free new data coming into Kafka, and then they realize, oh, that they're starting the streaming job, but there is no data to read. So usually people make this mistake. So specify the starting offset as earliest, and then you are specifying minimum partitions on Spark side. So this is saying, if we're going to read data from Kafka, how many partitions should we have on the Spark side? Usually you just want to match it to how many ever partitions your Kafka has. So in our case, our Kafka had 6 partitions. So I said minimum partitions in 6. One question people ask is when will I have more than 6, right? Or when will I exceed the number, which is, say, if Kafka has 10, why will I ever go more than 10, right? So only twice in 4 years, and by the way, I deal with like probably 4 use cases a week. So only twice in 4 years did I have to bump this number up to twice the number which Kafka had. And that was for latency specific reasons, that we had a lot of data in Kafka, and we wanted to split whatever data we got from Kafka into two parts such that we can process it in Spark faster. But other than that, just like for beginners, and even like I said, it's so rare. I'm just telling you in case you come across this problem, but um, just match it to how much ever Kafka has. And then there is this another parameter which is called max offsets per trigger, which is how many messages should I read every time Spark streaming runs. And that number I've set to 100, which is quite low because I don't have so much data. But you can really push this. You can push this to 100,000. You can really push this to 1 million. Honestly, if you're not testing, I wouldn't even specify this. So it's only for testing do I actually specify it. Or another reason I'll specify it is I have a very small cluster and my cluster does not have enough memory. So that's the only reason I'll set this number to lower. But yeah, other than that, that's how you read a Spark stream. And then what you do is there's this display command where you can display any data frame. So data frames can be roughly two types: a streaming data frame or a batch data frame. And you have this amazing display command in Databricks which you can use to look at the output. So then I read the output. There is a key, there is a value, there's the topic name, there's the partition number, there's the offset number, there is the timestamp of ingestion. And this, I just did some parsing of the data such that I could see what is in the data. But this essentially, when you're writing a first Spark application, you take this chunk of code and write whatever transformations you want on it, right? And you run the display command. And if you like what you see, then you take the next step of writing it into a table. That's all you need to do. So this is a very simple use case, right? I'm just going to read and I'm just going to write, right? Maybe I can do some small transformations if I want, or I can do mini transformations if I want. So one question people usually ask is, hey, you're just reading from Kafka and you're writing to a delta table. Why did you even bother doing that, right? So the answer is Kafka has a default retention policy. So Kafka is expensive. Kafka, Kinesis, all of these things are expensive. So if I go to my cluster, where is it? I have one topic. So Kafka has a retention policy attached to it. And the retention policy default is 7 days. So after 7 days, our data is going to disappear from Kafka. So that is why you want a local copy inside Delta, such that when the retention policy expires, you have the data to go back to. And that is why you want to do minimum transformations also. Because if you wrote some bad code, right, and you lost your original data, then there is no way to go back to, right? And retention policy, most of the times I've seen 7 days. Sometimes people do 14 days, 30 days, but that's the max I have seen in my experience. So that is why you want to read and just write such that you get a full copy of your data. And what else should I tell you? Yeah, and that's why you want to do minimum transformation. You can still do minimum transformation, but keep the original columns intact. It's that you have to make corrections. If you have to make corrections, then you have the original columns intact. That's the only advice I'll give you. Okay. After you have your you have the streaming data frame which you write. All you need to do is do a write stream call. And this is one best practice I'll tell you is you should give your queries a name. So here, when this streaming query is going to run, you will see I give it a human readable name. It will also get a unique ID, but you will see this name here. So I'm calling write Kafka topic something something, right? And the beauty of it is if you have 200 streaming jobs on a cluster, which you can, by the way, have 200 streaming jobs on a cluster, and you hit the structured streaming tab, you will see your, like, imagine if this was like an ID, you wouldn't be able to identify what it meant, right? So here having like a realistic name just helps understand on, hey, which stream are we talking about, if you have like tons of them. So here, what we are trying to say is, hey, take the streaming data frame, write to this target table. Here is our checkpoint location, and try to run this every 2 seconds. So here is processing time 2 seconds. You can change this. You can be like, hey, run every 60 seconds. You can be, yeah, you if you are in the second range, it makes sense. You do processing time. And then originally I told you, right, you don't have to run your streams all the time. So you can decide to write your code, but not have this pipeline run all the time. And the way you do that is basically you set this parameter, which is dot trigger available now equal to true. So if you do that, essentially the way the stream or your job would work is that it will checkpoint will identify what's there to be processed, and then it will process the data one batch at a time. And after all the data is exhausted, it will shut down the cluster automatically for you. So that's the benefit of trigger available now. And then if you want the job to run every 4 hours in your orchestrator, you say, hey, run every 4 hours, no code change required. If you want to say run it once a day, you just schedule your job once a day. If you want to run it every 15 minutes, you schedule the job to run every 15 minutes. And look at this. I'm not changing my code. My code is remaining the same. So that's the benefit of Spark streaming, which you have. Okay, now let me quickly. Now it's more of a deep dive. At this point, honestly, you have all of the things to get your first stream going, which is you. I told you how to store your secrets. I have told you how to set this max offsets per trigger for your testing purposes, or you can set it to a higher number. I have told you how to do a display, so you can look at what you have processed, and then I have told you how to write it right into a table. So this dot to table creates the table and also writes to it. Okay. One last best practice I'll tell you is the checkpoint location. I am storing in a temp folder, but ideally write like a function, like create a what do you call it? Create a class and create a function called get checkpoint location prefix. It's that you give it a table name and you get back the checkpoint location. The reason is you want all your checkpoints to be stored together. That's the reason you should have this. And the checkpoint should, I would say, should be always connected to the target rather than the source, because the checkpoint already has information about the source. So that's why I would say create a class and write a function or a method in it and get the checkpoint location such that your all your checkpoints for all your streams systematically remain in one place and you don't have to look around where they are. So this is for everything for beginners. That's all they need to know. Okay, to get your first streaming job done. And if you're on Databricks, scheduling is very easy. So change this to available now when you are scheduling your job, because in trigger processing time it will keep running like forever. So I changed this. So whenever the stream's outstanding data is finished, it will basically complete on its own. Just click the schedule button. um, so if you click the schedule button, you can say, hey, run every day. You can be like, hey, run every hour. You can be like, give it something else. You give it a machine to run on. And just one more small thing, don't set auto scaling on your cluster. So give it a fixed size cluster in streaming. So Spark streaming in a dedicated server mode right now does not have auto scaling. So just specify a fixed size cluster when you run your jobs. So if I click create, essentially I'll have a job created, and then I can keep changing its cadence. So I can change the cadence or whatever my business needs to be. So right now I'm saying, hey, run this job every hour. And you can even change this to be minutes. So you can say, run my job every 15 minutes. It will start the cluster. It will figure out how much data is there to process. And once done, it will kill the cluster. So I'm going to start speaking fast because I see I'm running out of time. But let me quickly show one more thing for you folks. This is for the advanced audience, just to be on the same page. So if you are a beginner, that's all you need to know. Don't worry about the rest of the stuff. Don't worry about it. This is advanced material. Again, we have the audience today was quite diverse. Some people had lots of experience with data engineering already. So this is for them. Okay. So if you already know Spark streaming, what else do you need to know? So first things first, your in processing rate should always be near your input rate or greater than the um, input rate. That just means, hey, Spark will be able to keep up with the input. So that's what that means. Next thing which you should look at is, so here you will find this metric called max offsets behind latest. So what Spark Streaming is doing for you is figuring out what's the latest offset in Kafka. So what is the latest message? And it knows where it is. And it does the difference and identifies how far is max offset behind latest. So if max offset behind latest is being is not increasing. That's what you need to focus on. It will always be behind, right? So because there will always be in a real life, there will always be something to process. So this number can't be zero if you have active data. But what should keep happening is this number should keep dropping. So as long as max offsets behind latest is dropping for your running streaming job, it means your processing rate is automatically greater than input rate. That's why this is happening. And you are not lagging behind. So your jobs are not lagging behind. So for your scheduled jobs or your jobs which are continuously running, that's the metric which you should monitor. Now let me tell you a few more things. Okay. So there are lot of things here. I won't be able to get into everything. So first thing I'll tell you is this has a sources folder. Sorry, yeah, there is a sources folder also, but this is saying, hey, I have a source. It's coming from Kafka. This is the name of my topic. And for partition 2, I am at 1876. For partition 5, I am at 5618. If you remember, I showed you in the PPT that every message has an offset number. So this is what Spark is trying to tell us, that, hey, for each partition, I'm at that specific offset. And if you're looking at 1 and 3, they are 0. That just means even the sample data set which Confluent created, they are not publishing data to all the partitions. So here you have a case where the partitions are imbalanced. It's very rare, but in this case, there we have a imbalanced partition. So that's what's there in the start offset. There is also one more thing more. This is this end offset. So Spark is trying to say, I am trying to read data between this start offset and this end offset. All of this information, by the way, is stored. And then this is the latest offset. So latest offset means what is the offset for the latest message. And that's how it can do the difference and calculate the max offsets behind latest, right? Hopefully that's making sense. Okay, now again, this is for advanced folks. Beginners, please ignore. So a lot of videos online does not actually tell how Spark streaming works. And it took me a while to learn all of this. But like for me, I can't just believe what anyone says. Like if Spark streaming says, hey, I can do fault tolerance and recovery, I'm like, hey, how can you do it? Like, how do you do it? I can't just believe it you on face value, right? So you won't find a lot of this material online, but here it is. So if you open a checkpoint, so we are listing our checkpoint location, you'll find 4 folders inside it, 4 or 5. So you'll find a commits folder, you'll find a metadata folder, you'll find a offsets folder, you'll find a source folder. Okay, so let's look at each of them quickly, and I'll go over. So I'll stay behind to answer everyone's question, but I want to really show what's inside this. So what is inside the sources folder? So inside sources folder, there's another folder called 0, and 0 has another folder called 00. Why these folders exist, my understanding is it's just such that when Spark streaming evolves, maybe it supports more sources. Right now only supports 1 or 2 sources. You can do stream 2 tables at the same time. So that's my understanding. And what it's saying is, inside one of these sources folder, it's saying, hey, I'm reading this topic, which has these partitions 0 to 5. And I started at 0th location for each of them. That's what the sources folder tells us. Nothing interesting. The most interesting folders are offsets and commits folder. Those are the interesting folders. So if you open the offsets folder, you will see that every time let's see what problem occurred. Live demos, folks. So problems occur. Okay, so in offsets folder, every time a micro batch finishes, a file is created inside the offsets folder and the commits folder. So let's sort this thing and figure out the latest offset. So the latest offset is 223. So I'm going to open offset 223 and show you what's inside it. I know this is complex, but if you're curious, like this is the depth which you want to understand this thing. So offset 223 folder was created at this timestamp. Now let's see what's inside the offsets folder. So to open a file, I'm using this command called dbutils fs head. Now obviously this is hard to read, right? So I created like a pretty print JSON function. So I'm going to pretty print this offsets folder. And honestly, if you understand offsets folder, commits folder is almost empty. I'll show you in a second. So everything you need to know about the stream is kind of inside the offsets folder. So it's telling us it's using HDFS backed storage. It's saying the Spark Shuffle partitions is 200, a bunch of other things. Most important thing it's storing is anytime a Spark job starts, it identifies what's outstanding. Okay. So this is saying I'm reading this topic, I'm reading this partition, and inside this partition, I'm going to start reading from offset number 3171. And now, if I kill my job, let me just kill my streaming job. And it already actually finished. Available now in practice. So let me start it, or let me show you first this. So offset folder, remember our offset, we were at offset number 223, right? Uh, Now let's look at commits folder. Because the job successfully finished, offsets and commits should be in line. So if offset number 223 is there and commit number 223 is there, so it's saying that, hey, whatever I had said I'll do as part of offset 223, I have finished. It's committed. Now, if I just remove this folder, essentially it would reprocess the offset. So that's how things work. Now, if I start this job once more, I'll start it. It should create offset 224. And if I kill it midway, the 224 commit wouldn't be there. So let me kill it. Now, if my kill happened successfully, now it might also not happen successfully. Then so you'll see offset 228 and I killed it midway. So hopefully my commits folder 224 did not commit. Obviously, if I didn't kill in time, clearly I didn't commit in time. So there are other things too. But yeah, here is what I'm trying to tell you. The way Spark Streaming identifies what to process is because checkpoints offset folder remembers what is there to process. And if offsets folder and commits folder are not in sync, meaning offset number 227 does not match with commit number 227, that means that the job was killed somewhere in between, right? So that's why you can kill the job somewhere in between, and when the Spark Streaming job starts again, it will just recover because it knows that it had promised it's going to process an offset, but it did not commit. That's about it. Now let me just show you this metadata folder. There's nothing interesting inside it. Actually, I didn't show you the commit folder first. So sorry, for commits folder is very simple. Commits folder does not have much. It barely has any information. It has just some water mark information. So all it's having is, hey, just figure out if offsets and commit numbers are in sync. Metadata folder also doesn't have much information. I'll just show you what it looks like. It just has the ID number of the stream, and this ID number is going to match what we see on the streaming UI. Let's see. So sorry, I restarted my stream. So it's somewhere here. Maybe this screen is not refreshed, but this number which you see, oh, this is my old stream. This is my old checkpoint. That's been not there, but this number would match with this one, this stream ID number. So that's what it's going to match with. Okay, so that's about it on the depth of streaming checkpoints folder. I had another thing about state, but I thought it's too much to convey in a single session. So maybe next time we can cover Spark streaming with state. Today what we covered was Spark streaming without state. Okay, so what's next? So if you want to keep in touch, basically you can subscribe to Substack. The link is going to be in the YouTube video description. If you want to talk to each other, I have two things. I have Discord as a server. I have a Discord server where you folks can talk to each other. We all are trying to learn, grow in our career, trying to learn Spark or other ways to enhance our skills. And then I also started a new WhatsApp channel where you can keep in touch. If you want to speak to me one on one, you can find me on Discord. You can find me via my website. General questions you can always ask on WhatsApp and Discord. So what's next? Right, for the next session, I was going to plan of having. I wanted to show you how you can take a regular Spark job and convert it into a streaming job without code changes. When is the next session I'm going to do? It's going to be in the next 2-3 weeks. If you follow me on Substack and Discord, essentially I'll be able to send you a notification. Subscribing on LinkedIn does not really help much because I might not show up or you will not get the notification on your wall. Okay, so I hope you folks have a lot of questions. Now I'll look in the questions, and again, if you have questions on this content, good. If not, you can always also ask journal questions of what you see in the field. Okay, so the first question I see is I'm trying, Chris, sorry, I don't know this name, but I'm trying to build a solution that replicates around 100 tables where transactions are sent via Event Hub, and the high level architecture, hold on, what is this person saying? Where transaction is sent via Event Hub, high level architecture is Event Hub, Delta Rod, Delta Stage, and the columns are unfolded. Okay. After that, this is a long question. Merge to final table, data is transferred. How should I workload be distributed across the cluster? How do you solve the problem? Okay, so essentially, the crux of this person's problem is the person is also saying I'm not a fan of DLT. I okay, I'll get to that also. So, crux of the problem is you have hundreds of tables. This person has 100 tables. So you have 100 tables, which is for which you are getting new information from Event Hub. Event Hub, by if you folks don't know, Azure's Kafka implementation, you can say is called Event Hub. Again, it's a oversimplification which I'm doing. But on Azure Event Hub, you have a Kafka connector. That's what you can use to actually read this data. Now you have 100 tables. I'm assuming those 100 tables get their unique topic. Okay. So what I would say is, um, I actually have done a use case where you had like 40,000 tables. So 100 is very easy. So what you can do is you can, on a single cluster, you can start 100 stream. Each table should get its own stream. Okay. That's one way you can do it. And as long as they are like different topics, so if you have 100 topics, I'll have for each topic I'll have a separate stream, and then you just read the data and write it into your bronze table. So now you have a replica of your Kafka tables, right? So 100 tables became okay. So the person saying unfortunately I have one topic, so no problem. This is what you can do. So if you have one topic, meaning the messages from all the all the tables are coming into one topic. So let me go back to the architecture, or let me see if I take the architecture right. Okay, so if you look at this example in this person's use case, uh, they have one topic which represents 100 tables. Okay. So what you can do here is, at least, okay, let's work backwards. For each table you should process independently. Okay. So at the silver layer, you should have 100 streams for sure, because it's not expensive. You can have 100 streams run on the same cluster, no problem. Your CPU will be well utilized. You'll still be okay on cost. So you can have your 100 you should have 100 streams in your silver table layer, each table getting its own stream. And in the bronze you can have like a single table, and just the silver bronze table essentially is just going to store whatever Kafka has. So that's how I'll design it. First table is one stream, one bronze stream getting all the data from all of those tables. And in silver I'll start basically decoupling them. And you can write a for loop also within your code. So basically, you can write the parsing logic once and have like a loop create 100 checkpoints. And you can think about DLT as well. I think DLT is a good use case because it has auto scaling, but if you want to do it outside of DLT, that's good too. But yeah, that's how I would solve it. Let me see if I missed something. No, I think this is good enough. This should do it for you. Yeah. Any other questions on the live chat, folks? Okay, going once, going twice, going thrice. Is someone typing? I don't know if someone is still typing a question, but I'll wait. But if not, so the next session we are going to figure out how to convert a regular Spark job to a streaming job with minimum code changes. When are we going to do it? In the next 2-3 weeks. And if you want a notification on hey, when is this event scheduled, subscribe to Substack and Discord, and then you'll get a notification. Yeah, hopefully that makes sense and you folks learned something. Yeah, nothing else from me. Have a good day, folks, and thank you for joining in. And if you have any feedback, feel free to just message me on LinkedIn or Discord. And yeah, happy to adapt. Bye. Have a nice day. Bye.